This is the Smart Buildings Academy podcast with Phil Zito, episode 210. Hey folks, Phil Zito here, and welcome to episode 210 of the Smart Buildings Academy podcast. And in this episode, we are going to be talking about making your BAS data work for you. And before we do that, I want to let you know that everything we discuss can be found at podcasts.smartbuildingsacademy.com/210. Once again, that is podcasts.smartbuildingsacademy.com/210. All right, so I was listening to James Dice's most recent podcast on Nexus, and he was going through a bunch of analytics frameworks, a bunch of data things, schemas, stuff like that. And one of the things that got me thinking was we often have a lot of talk about schemas, about ways of organizing data, about platforms. And we talk at the theoretical level about organizing data and structuring data and consuming data. But what I wanted to do was talk about actually what data was, why we need it, how we capture it, and then how do we make it work for us, and actually talk through several real-world scenarios that I encountered during my time working with the system integration program at Johnson Controls. So I'll talk to you about the challenges we faced from the perspective of actually taking data and making sense of it, and why you see so few smart buildings, why we actually are still pretty archaic in our technology sets that go into buildings. So what data is, at least from the perspective of building automation, is information. It is truly information. And to understand where this information comes from, we have to take a kind of time travel trip back to when controls were still pneumatics, analog, and electromechanical systems. You know, it is essentially fairly recent that we switched over to direct digital controls. They've only been around for 20, 30 years now. And it's only real recently that we started to push a lot of the supervisory capabilities like trending and data logging and analytics into the actual edge field controllers. So why does that all matter? Well, what used to be is that you could see data on gauges or on your electromechanical thermostat, but you couldn't do anything with it. I mean, it wasn't electronic. Well, that all changed with direct digital controls. Direct digital controls enabled you to take analog systems, analog data, and actually convert it into digital signals. Digital signals are ones and zeros. Now that we had this data, whether it be temperature sensor, humidity value, etc., in the form of ones and zeros, we were able to do things with it. And at first, we just had these application-specific controllers, and they would process the data. And we then realized, hey, we can actually communicate this data and we can view this data. So we created field trunks, and we created supervisory devices to supervise those field trunks. And we utilized thick clients to go and pull data out of those supervisory devices and present them to a graphical user interface, also known as GUI. In order to communicate all this data, we had to create protocols, because protocols are rules of communication. They structure the syntax and the organization of the data as it travels from one device to the other. Now, initially, these protocols were proprietary, and they were that way because there just wasn't anything really out there. And so each manufacturer kind of had to create their own protocol. Now, fast forward, and we have LAN, and we have Modbus, and we have BACnet. We have multiple different protocols of transfer, or that are focused on transferring data. And each protocol has its own data model. Now, a data model is essentially a model of how data is structured. With BACnet, you have devices, and those are types of objects, and those devices have properties. And basically, every object has properties, and some of the objects, like devices, can hold multiple objects inside of them. And that is a data model. That is a way of modeling the data inside that object. It's you could technically argue that it's an object model in which there are data models if you wanted to get technical about it. So these data models, right? These data models that are being utilized by these BACnet device objects, they were then, right? That data was then taken and stored in databases. And so what we would do is we would capture this data, usually in the form of trend logs, and we would store it in databases. And these databases would exist in database servers, and they were usually relational databases, which means that there is a relationship between the data, and that relationship is usually in the form of primary keys that connect tables. Now, what is a primary key and what's a table? A table is just an organizational structure of which we hold data, and a primary key, secondary key, etc. What those are unique ways of identifying data within that table. So, for example, you may have a table called VAVs, and your primary key may be the VAV number, and that VAV number should be unique so that when you would click on VAV1, you would have all the data associated with it in the table. Maybe it's zone temp sensor, maybe it's damper value, etc. That's how all of these trends get stored. They get stored in the databases. Now, how do we use this data? Right now, we use it by pulling it into Trend Viewer or maybe running reports on it. And all that's doing is just doing a simple query against the database, whether that's locally on the supervisory device or if that's in the database server. But we're grabbing it and then presenting the data either on the user interface in the form of a trend viewer, or we're going and generating a report. That's how we currently use data. Now, the question is, how can we make data work for us? So I'm going to focus on that, and then we're going to shift gears and we're going to talk about data conversion. And we're going to talk about basically data adaption, all the things you need to do in order to create a smart building. And then we'll talk about how in the time of post-coronavirus, or depending on when you're listening to this, current coronavirus, it makes a lot of sense for us to have data analysis capabilities. So how do we make data work for us? Well, the first thing you need to do in order to make data work for you, and we're just going to look at the building automation system right now, and later in this episode, we'll look at integrated buildings. But I feel like one of the biggest problems we run into as an industry is when we look at making data work for us, whether in the forms of trends, alarms, whatever. The problem is we don't have any unified strategy. So we have no standard. We have no organizational standard for our organizations. And that's the first thing we can do to make data work for us, is we can organize that data. We can make sure that we have consistent naming standards. We can make sure that our trend log interval periods actually make sense. If you're sampling, for example, zone temp every 15 minutes, and you're also sampling damper position every 15 minutes, you're not really going to be able to troubleshoot a space, because we all know that the damper position changes more than once every 15 minutes. So while you may say, oh, well, every 15 minutes because we have 4 air changes an hour, that should be fine. But we really need to see what the damper is doing, maybe at a 30-second basis. So we need to go and make that data work for us by having standards for naming, standards for trending. The next thing we need to do for making our data work for us is that we need to make it available. So it's one thing to have standards. It's another thing to actually apply those standards and have naming standards, trend standards, etc. It's a whole another thing to make it available. What do I mean by that? Oftentimes, we will go and trend our devices in our supervisory, or we'll trend our objects in our supervisory devices, And then we'll just let them sit in the buffer. We'll let those trend records sit in the buffer on the supervisory device. And after 500 record samples or whatever you have it set to, that data gets overridden. It's no longer available to us. In order for us to do anything we'll talk about later, data conversion, data analysis, we have to have data available to us, because what you'll find as we get into analytics, as we get into data visualization, you have really two ways. You can visualize now, and you can use analytics to do proactive fault detection, or you can analyze the history, which is what most people do, and that requires actually having data that is available to us. So making sure that we have a strategy to store that data, making sure that we are storing that data, making sure that we're capturing the right data. All of this is critically important for us if we want to go and actually make data work for us. So let's talk through some scenarios and where we might want to make data work for us. Most common one, space control. How often do you get hot and cold calls in your spaces? It's quite possibly the most common issue faced by facility teams, hot and cold calls. Now, the problem with hot and cold calls is often you get the call and then you go look at the system and the system has already adjusted itself for the call. And then you try to go look at your trend history and you don't have the data. So what we need to start to do is, if I'm sitting in your shoes, I'm thinking about the trouble calls I get most often. I'm thinking about how often I get those. I'm thinking about what data sources I use to analyze and troubleshoot those. And then I'm thinking what data intervals I need to set in order to go and troubleshoot that. So in the case of a space, I may want to go trend zone temperature. I may want to go trend damper command. And I may want to trend CFM flow or flow value, whatever it is. And I want to trend those. Usually what I will do is, if I have the capacity, I will do COV actually on each one of those. And I will use about 2% of the effective range as my COV threshold. So what that does is that decouples us from interval, and that now couples us to change. And we want to look at our trends based on change, not based on intervals. Now, it used to be that supervisory devices did not have the resources and capabilities to process COV. Field trunks really couldn't handle it, and field devices couldn't handle it. If you have a modern BAS, that is no longer the case. As I've said in many, many, many podcasts, anyone who's telling you that running COV or running rapid sample periods on your BAS data is going to overwhelm your network, they do not understand data or networks, because if they did, then they would know that BAS data is microscopic. We're not talking about 4K video streams here. We're talking about bit-sized data. Even if you have thousands of points, we're talking about very small data streams being sent and processed. So even going and setting up a lot of processing of data is not going to be terribly impactful. Where it does become impactful is when you do not respect the resource constraints of your devices. So for example, if you were to take a supervisory device that was really designed for 100 devices, and yet you do BACnet IP and pull in 1,000 devices and start trending all of them, that supervisory device is not going to be able to handle all that. That has less to do with the impact of trends and more to do with you exceeding the actual capacity of the device. So it's critical that you understand what that means, that you understand device capacity and how that affects your actual collection of data. Okay, so let's say you've collected all this data, right? Now what? You may want to do some form of integration, and this is where things become difficult. You know, a common integration that I've seen time and time again is to integrate lights and spaces. Now, herein lies the rub. With a lot of lights, they are set up in zones, and zones can exist across multiple spaces. So whereas we, as building automation folks, we set up spaces, and they typically have a space temp, and it's a constrained area, except for like in crazy office, open office designs. But whereas that space is a constrained area, the zones are not. We can actually have a lighting zone that can float across multiple spaces. So how do we resolve that? What we have to do is data adaption, and we use what's called a data adaption model. And in order to do that, what we will often have to do is we will have to create a logical model where we say that that zone is actually equal to these spaces. And then we have to make a decision. Are we going to let the occupancy for the lights control the space occupancy, or are we going to let the space occupancy control the lights? And if so, what are we going to do? Are we going to say if one space is occupied, then we turn on the lights, or is it if two or three? That's basic data adaption. We're not even doing data conversion yet. We're just doing an adaption model, which means we have this model that sits on top of the lighting data model and of the space data model. And it essentially goes and says, okay, this lighting zone matches up to these spaces, and this is how we're going to control it. As you start to move into complex system integration, where you are doing multiple systems, maybe you are doing a conference room scheduling system in the AV system, and you've got lighting, and you've got temperature control and space control in your BAS, and you have maybe some sort of security system as well. Now, with all those different systems coming together, that's where we have to use this data adaption model. So data adaption is actually what we are going to do for most of our integrations. People who tell you data conversion is what you're going to do for most integrations have not done a lot of integrations, because I've done a lot of integrations. I've done hundreds of integrations. And most of the time, I would say 95% of the time, when I'm doing an integration, I'm not sitting there doing data conversions. I'm not going, oh, this is a float, I need to convert it to a decimal or to an integer because it cannot hold the decimal values and da-da-da. No, that's not happening. What I am doing is I'm doing an actual model. I'm saying, okay, this is a lighting system with these zones, and the AV system is grouped by these groups, and these spaces are grouped by these spaces. And I need to make all of this make sense, and I need to pick which master system is going to control it. Honestly, most of these systems speak BACnet IP, or they speak some sort of RESTful API, and going and pulling that into your BAS, if it is a semi-modern BAS, is fairly easy. The problem I see with a lot of data integration is that people don't understand protocols and they don't understand APIs. They call themselves integrators, but then you ask them to explain how BACnet IP works and they don't understand it. Or they don't understand how an API works and how RESTful API calls work. That is not a data conversion problem. That is just not understanding how to pull data into a system. I know I went off on a tangent there for a second, but it just really frustrates me when I'm seeing all of this, hey, we need to do data conversion, hey, we need to do tagging, we need to do metadata, da-da-da-da-da-da-da, and that's the solution to everything, when in reality, the biggest issue with all of this integration has more to do with the disparate modeling of data and not the actual data types themselves. I hope that made sense. I went a little geeky there for a second, but I feel that if you get that little kind of segue I went on there for a second, that will really help you out in your quest to do integration, because the problem almost always is the data models and making them match up and not the data types. Because at the end of the day, most BAS support pretty much every data type. I've yet to run into a lot of scenarios where I couldn't pull data into a BAS because the data types didn't match up. Now, all that being said, we are going to run into some scenarios. So I've worked on some hospital projects where we had to consume HL7 feeds. Now, HL7 feeds, at least version 2, are in strings, and it's clear text in a string. And in that case, you do actually have to have some form of data adaption, like a regex script or something that is running against that data, and then it's parsing that stream and pulling data out of that stream and then typing it into BACnet objects. So there is that. And I will tell you, though, that data conversion that I'm talking about right there, right? Reading an HL7 stream, parsing through it with regex, grabbing data from it, and then assigning it to BACnet objects. That kind of conversion I rarely see in building systems. I rarely see that we have to do that in building systems. So lighting systems typically speak BACnet. Access control, they speak some protocol that is going to be able to be pulled into the most BASs using a driver of some sort. Power monitoring, right? Modbus. Your actual AV systems, most of them speak BACnet. Your scheduling systems, usually some sort of API that you can pull right into your BAS. It's only when we get into like some funky legacy systems that have weird streams or custom protocols that we actually have to do data conversion. Now I want to spend a little bit of this to talk about tagging, to talk about metadata, because you may be like, Phil, you just said tagging and metadata aren't important. That's not what I said. I just said it's not the most important. If I'm trying to pull data into a system, the first thing I need to do is get the data into the system. Only when I have that data in the system can I actually go and provide semantic metadata to it in the form of tagging or however you want to go about structuring that data so that it's more quote-unquote queryable. So let's talk about metadata and tagging. So metadata is basically data about data. So if you've ever looked at a BACnet analog input or analog value, you know it has a bunch of different properties, right? That's essentially what metadata and tagging is to our objects. It is just basically adding a property, usually in the form of key value in JSON format, and you're providing this data in the form of tagging, right? So you're tagging the object. You may be saying this object is tag type zone temp. This object is tag type supply fan, or this is tag type lighting. The purpose behind this, honestly, in my experience, is less for BAS and it's more for systems that rely on data from the BAS, because a lot of these systems, the analytics systems, the visualization systems, work order management systems, they have trouble making sense of what BAS data is, because ZNT may mean one thing and space temp may mean another thing and room temp may mean another thing. But in order for that to make any sense, you need some structure. And tagging provides that structure. So what tagging enables you to do, and what ultimately metadata enables you to do, is to provide some organizational context, some context to your data, so that these solutions that sit on the top end of your building automation system can process this data. Because at the end of the day, if we're doing analytics, which a lot of you are going to be doing analytics in the very near future. I am just waiting for some regulatory body to come out, like Joint Commission or like the FDA has for healthcare and for the food industry, respectively. I'm waiting for some organization like that to come out and apply IAQ policies to buildings and to require logging to validate those policies, at which time you are going to have to start consuming data from multiple building systems, consolidating those into some system, and then presenting that data for review. And it may get to the point where you actually have to implement analytic rules to effectively monitor IAQ standards, maybe on ventilation rates or maybe on humidity rates, like ASHRAE 55 stuff and ASHRAE 62.1 stuff. It may become where you have to actually report on that, and in which case now the metadata aspects become kind of nice, because what you can do is you can easily pinpoint, oh, that's CO2, or oh, that's zone temp. So metadata becomes valuable there. But the biggest challenge for most of you is going to be retrofitting your systems so that you can do data consumption, so that you can pull data from all these disparate systems and present it into a front end. So what I hope you're taking from this is you are going to see a lot of stuff on LinkedIn. You're going to see a lot of stuff at conferences, and people are going to be talking about all of these things, brick schema and haystack and all these different metadata tags and using Python to do data analysis. And that's all well and good. But for most of you, that is overkill. For most of you, what you really need to know is how to normalize data models for integration. And you do that by, most of the time, what you'll do is you'll map in the data from the lighting system, you'll map in the data from the building automation system, and then using global logic, you'll do some sort of conversion. You will go and say, okay, I'm going to use an enumeration set, or rather, not an enumeration set, like I'm going to use a mux block or a demux block to go and use states to drive multiple zones, to use an occupancy. Like you could use, I think it would be like a demux. I'm not looking at programming here, but it'd be a demux where you'd say, okay, occupancy is going to command these 4 zones. And that's kind of how you would go about doing that data model to kind of coalesce the lighting and the space control together. I know this has been really deep, and I don't really talk about this kind of stuff too often. I know it's fascinating. I know it's really interesting to a lot of you. I'll be honest, this is not going to get you promoted. This is probably a percentage of your executable backlog on a day-to-day job. The reality is you would be much better off investing in getting solid at programming and solid at doing graphics than going and learning complex integration. However, that being said, there are some of you who are going to go and have to execute integrated projects. And in that case, this information is going to be valuable to you. So what I want to leave you with, if you find yourself in a scenario where you're having to integrate systems, figure out the data model. That is the key thing. If you can figure out a singular data model, kind of that data adaption, to bring those 2 different disparate data sets together, you're going to be awesome. If you do find yourself working with some funky data, in that case, you will find yourself in data conversion, but most likely if you're working with that kind of funky data, you already have that skill set to work with it. And finally, tagging and metadata, while I feel it's important and it does definitely provide context for those higher level software suites like analytics and the like, it is not critical. I would much rather have you work on a graphics and naming standard than spending your time working on a tagging standard. I think it's important, but I don't think it is the most important thing. Now, I'm sure there's several of you who disagree with me. That's fine. Hey, we're in a free world, right? At last I checked. But at the same time, I will tell you that this is based on my experience doing hundreds of buildings, hundreds of complex integrations, and a lot of crazy stuff with a lot of really cool technology. So take it as you will. That being said, I do want to thank you for being here. I hope that this gives you a different look at data. I hope that this gives you a different perspective of integration, data modeling, data adaption, and data conversion. I know we just kind of touched at it briefly. If you do definitely want to dive deeper into this, I'd encourage you to check out our System Integration Bootcamp course, where we spend several hours going and actually consuming APIs and creating backnet stacks and doing complex data conversion. I will tell you that if you are wondering if that course is for you, it's probably not for you. It's really for people who are going to be doing complex integration on a regular basis. So I don't want you going and enrolling in a course that is not really going to benefit you. That being said, thanks a ton for listening to the podcast. I'm so happy you're here. Be sure to check out our new site, smartbuildingsacademy.com, and check out this podcast at podcast.smartbuildingsacademy.com/210. I hope you all have a great day, and I look forward to talking to you in next week's episode. Thanks a ton, and take care.